space. An empty place. Empty? Not quite. Here, from a respectable distance, you can see our Milky Way. Below the Milky Way you can see the two companions of our galaxy, the Small Magellanic Cloud, SMC, and the Large Magellanic Cloud, LMC. Like humans, stars tend to keep together in groups, the galaxies. Their binding force is gravity. We are now approximately 10 million light-years away from our Sun. Starting off with a speed of more than 1 million light-years per second, we will gradually decrease speed to 100 light-years per second when we are inside the Milky Way. Even with an average speed of about 1,000 light-years per second, it still takes 45 seconds to get in the neighborhood of the Sun. At light speed, it would take us 10 million years. At a distance of 100 light-years from the Sun, we will stop movement for a while. Now let's get off. Zooming out a bit to better see the stars. Now, at approximately 100 light-years from the Sun, we have stopped moving. Did you notice the density of stars growing when we got nearer to the Milky Way's disk? There are far more stars within the bulge than at the edges. The highest star density, after all, is at the center of the Milky Way. Let's enable constellation rendering. The constellations do not look very familiar. That's because what we see from Earth as flat figures are actually lines between stars that may be very far apart. Now watch the constellations take on their familiar form when we approach the Sun. And there she is. The Sun, surrounded by the inner planets. We are now going to view the Sun and the planets around it from above. Notice that the planets close to the Sun orbit faster than the ones farther away. Also look at the speed of Mercury. It increases when it approaches the Sun, and it decreases when it moves away from the Sun. Off to Pluto. Pluto is in many ways not an ordinary dwarf planet. It has a very eccentric orbit, and its moon Charon is, relatively spoken, exceptionally large. Charon orbits Pluto very slowly, so we have to speed up time a lot to see it moving. As you may have noticed, their respective center of gravity is not located around Pluto itself, but outside of it. Let's move a bit around Pluto. Until 2015, we did not know how truly spectacular this formous planet is. Bye-bye Pluto. Let's go to Neptune, one of the 4 gas giants of our solar system. Like most gas giants, Neptune has a lot of moons. We will visit one of the moons, Despina. While Despina is in view, look out for the other moons of Neptune. You will sometimes see them make retrograde movements. Next stop, Uranus. Uranus is also a gas giant. And again, this planet has a lot of moons. All gas giants have rings. Sometimes, as is the case with Uranus, they are very thin. Leaving Uranus. Up to the Lord of the Rings. Some of Saturn's moons are inside the rings. Look carefully. They are called the shepherd moons. The ring seen from below. And from above. Diving through the rings. Leaving Saturn. Up to the last and largest of the gas giants, Jupiter. At Jupiter we will do a moon hopping trip. We will visit the inner 9 moons from the outside to the inside. Jupiter will constantly remain in view, so it will appear larger and larger during the trip. Themisto. Callisto. Ganymede. Europa. Io. Vape. Amalthea. Metis. And finally, Adrastee. Off to the red planet. Mars, the red planet. In a low tempo we will visit some of the remarkable places of this planet. Vies Marineris. A Zagreus Mons, Pavones Mons, Archer Mons, and, to the left, the large Olympus Mons. Finally, the North Pole that, just like Earth, has an ice cap. Our home planet, Earth. For Earth we have 3 scenarios in store. 1. Follow Earth from the Sun during its yearly orbit. 2. Watch the phases of Earth as seen from the Moon. 3. A visit to the ISS. Scenario 1. Follow Earth from the Sun during its yearly orbit. Scenario 2. Watching the phases of Earth as seen from the Moon. Occasionally the Moon will cover a large part of the screen. Scenario 3. Following the ISS. Locating the ISS. So much for Earth. Venus. For Venus we have a simple but nice scenario. We'll track its course while heading for the Sun. When Venus covers the Sun, wait for the Sun to pop out under it at the bottom left. Last stop, Mercury. At Mercury we have a very special view, a double sunrise. Due to the ratio between its orbit time and the time of a Mercurian year, combined with the large gravity field of the Sun at this distance, sometimes a double sunrise or sunset occurs at Mercury. Now watch for the Sun while it hesitatingly rises from the left. And again. While casting a last eye on the Sun, we are now leaving the solar system. And the Milky Way. Thank you for watching.